Hello and welcome. Today we are going to be looking at the Gauss-Jordan elimination method of solving systems of linear equations with the help of a calculator. Consider the question presented before you, which has four variables. If you have a question like this and you are to use the Gauss-Jordan elimination method to solve, what should you do? The first thing is you have to take the coefficients of the variables here and form an augmented matrix. So we are going to do that now. Solution. We have, for the first equation, we have -1, -2, -4, 1, and then we separate the right hand side with a vertical bar, -10. For the second equation, we have 2, 7, 14, 4, and 26. The third, we have 1, 4, 9, 6, 13. And the last one, which is the fourth, is 4, 10, 17, -5, and 43. We are done with arranging it in an augmented matrix form. Remember, the aim of this method is to make the elements below the diagonal into zeros and those above it also into zero. The diagonal is this, from this point up to this. That is our concentration. So to do that, we have to carry out row operation. And for us to have a zero from here and here and here in the first column, we have to take from row 2, we have row 2 plus 2 row 1. We know that that will give us a 0 here. Then row 3, we also add it to row 1. And then the last row, which is row 4, we add it to 4 row 1. And we can impute that in our calculator so that it gives us the answers. But let us first of all name our row 1A, row 2B, row 3C, and row 4D. And that is the name we are going to use for it in the calculator. So we take row 2, we say this B, so alpha B, we plus 2, alpha again A. We are done with it. So when you are done with that process, you have to separate it with a colon. We press alpha key and this key which contains the sign of integration. And we move to the next row, which is C plus A. We move to the next one, D plus 4A. Now we write our second matrix. Remember, we are not going to do an operation on row 1, so we take it the way it is, just exactly. Nothing will change. But for row 2 now, we ask the calculator to calculate for us. When B is 2, C is 1, D is 4, and A is -1. So B we said is 2, A we said is -1, C is 1, D is 4. So we have 0 for B, 0 for C, and 0 also for D. Of course, we had already known that it will give us the zeros, but for the sake of confirmation, we had to test it and see. And that was why we had to enter it in the calculator. But now we move to the second column, which we press equal to sign. B here is 7, A is -2, C is 4, D is 10. So the answers are: for B we have 3, C we have 2, D we have also 2. Equal to sign again. For the third one we have 14 for B, -4 for A, 9 for C, and then 17 for D. So B is 6, C is 5, and D is 1. We proceed to the next column. B is 4, C is that is A is 1, C is also 6, and D is -5. Our B here is 6, C is 7, and our D is -1. The last column, our B is 26, our A is 10, -10 actually. C is 13, and D is 43. So 6 for B, 3 for C, and 3 also for D. We proceed with the operations because we want also to get zeros here. So let me also say here that when you are in column 2, make use of row 2. Don't go back to make use of row 1. So we are going to make use of this row. Now we have to take 3, row 3 minus 2, row 2. We take again 3, row 4 minus 2, row 2. We know that that will actually give us the zeros we want here, but we have to define it also in the calculator, the operations we have here. We have 3 alpha C minus 2 alpha B. We are done with that. We proceed 3 alpha D minus 2 B. Now we write our matrix. We have -1 for row 1, -2, -4, 1, -10, because the row will not change. Row 2 also will not change. We take it as it is. But when we come to row 3, we know that the first 0 will not change, and even in the fourth one. But we now calculate for these two. When C is 2, B is 3, and D is 2. What do we have? Of course, we had expected these zeros. We proceed to the next column. B is 5. Sorry, C is 5. B is 6. And D is 1. So we have 3 for B, -9 for D. We proceed again with the next column, which is column 4. C is 7 in that column, B is 6, and D is -1. The values are 9 and -15. Our bar is there. We proceed. C here is 3, B is 6, and D is also 3. We have -3 for B, -3 also for D. We are done also with that step. Now we proceed with the next matrix. We have to still make this a 0, but remember we had said that we want this whole diagonals to have 1s. So let's also change these 2 into 1s. So we can take row 2, we divide it by 3. We take row 3, we do the same. We know that that will also give us ones, and it will make our work easier. Then for row 4, we have to take row 4. Now we add it to 3, row 3. We enter the operations in the calculator. We have B should be divided by 3. We are done with that. C should also be divided by 3. We are done also with that. And then for row 4 is D. We add it to 3. 3 is should be added to 3C. Now we write our matrix. For row 1, it will remain the same because it's not going to change. There was no operation on it. But we're asking the calculator to calculate for us when B here is, this is B for row 2. This is the row we want to work on now. It's actually 3. See, the rest of them are zeros. So B is 1. So we start with the 0, and here is 1. Here also, let's take these zeros because they will not change. So C is also 0. We have already returned it. D is also 0. We write it like that. The next column, we have B 4. This column is 6. C is 3. And D is -9. What do we have? We have 2 here. The next we have 1. And the next we have 0. We go to the next column, which is our B here is 6. C is 9. And then D is -15. We have 2 also here. B 3 for C. And then for D we have 12. We do the next operation. We have B is 6. C is -3. D is also -3. So our B is 2. Our C is -1. Our D is -12. But for us to have 1 here, we have to divide row 4 with 12. Let's also multiply this with -1 so that we change this into positive. That we do not actually need a calculator, as it is simple to calculate. When we times everything here by a -1, we have 1, -2. Sorry, it's no more a negative, it should be a positive. So this is the matrix we will end up with after the operations here. Row 4, we divided it by 12. So our ones here are obtained. Our zeros down here are also obtained, but then the upper part of this matrix, which is the upper triangular matrix, also has to be zeros. How do we do that? Now we have to start from this column 4. So we take row 1, we add it to row 4. We take row 2, we subtract to row 4. We take row 3, we subtract 3 row 4, and we will enter sum into the calculator. So we have A plus D. We have B minus 2D. We have also C. Before then, let's end that process. So we take C minus 3D. Now we can write our matrix. Let me say here that when you come from the third column to the first one, everything will remain the same because of the zeros under here. So let's write that as it is. And then the rest of the operations continue. Now let's use the fourth row. So we ask the calculator to calculate when A is -1, D is 1, B is 2, and C is 3. So D, we know here should be 0. B also is 0. C also is 0. D, there was no operation on it, so we maintain the 1. Our vertical bar still remains. Now we enter again. Our A here is 10. Our D now is -1. B is 2. And C is -1 also. So we have 9 in row 1, 4 in row 2, 2 in row 3, and then for A, D, we did not do operation on it, so it has to remain like that. We are done with that operation. So we need also a 0 here, here, and here. So we proceed. We say we are in column 3, so we use also row 3. Now we take row 1 minus 4, row 3. We take row 2 minus 2, row 3. We define it in the calculator. We have A minus 4D. B minus 2, sorry, it's not actually D, here is C, because we are on row 3. So it's 4C, not D. So B minus 2C. Now we write our matrix. Our first two numbers will remain the same for all the rows. But in the third one, we are asking the calculator to calculate when A is 4. And then our C is 1 our B is 2. So we have a 0 here. Next is also a 0. So the rest will remain the same because there was no operations on them. Here, since the two of them are 0, we just maintain them as they are. So we calculate again for the last column. A is 9, C is 2, and B is 4. So we have 1 here, 0 for row 2, and the rest of them will remain because there was no operations on them. We are almost done. So if we proceed with the last operation, we want to make this 2 a 0. Now we take row 1 minus 2 row 2. We can write that matrix here. We have the rest of the rows will remain the same, so let's write them out. 0, 1, 0, 0, 0. We also have 0, 0, 1, 0, 2. We have 0, 0, 0, 1, and negative 1. Now, for the row 1, we are saying row 1 minus 2 row 2. We know that 1 will remain, but 2 minus 2 times 1 should give us a 0. The rest of them are 0, so they will maintain as they are. Here we have row 1 minus 2 times a 0 is T1. So remember, this is our x1, x2, x3, and x4. So this is the column for the answers. So for our x1, the answer for it is 1. Our x2 is 0. Our x3, which is this, is 2. And our x4 is negative 1. If you actually confirm this in the equation here, you will get the answers as this. So the system has been solved in this way with accuracy and more of a speed than when you do the whole thing the way you should do manually. Thank you for watching, and may God continue to bless you as you subscribe to our channel.